In this video, we'll discuss running the Random Forest Classifier function using UnifyML SQL. Running your UnifyML Random Forest Classifier algorithm using a UnifyML query. Here, we execute the UnifyML Random Forest Classifier function. Now, let's take a look at a simple UnifyML Random Forest Classifier. Before running the classifier, let's first examine the dataset used for training. The table name is heart disease. I am limiting the query. Run this query. This query will execute in the backend of our UnifyML server. The dataset includes features such as age, gender, chest pain type, blood pressure, cholesterol, and fasting levels. These are the input columns or feature columns, while the target column is heart disease. The goal is to predict whether a patient has heart disease based on these features. For this, we use the UnifyML Random Forest Classifier. To configure the classifier, specify the required input table and input columns, which serve as the feature columns. The target column to be predicted is heart disease. Hyperparameter tuning can be applied to optimize the model. There are two types of hyperparameter tuning: train validation and cross-validation. Parameters that can be adjusted include max bins, which define the maximum number of bins, max depth, which determines the maximum depth of the tree, min info gain, which controls the minimum information gain, and seed, which acts as the random seed parameter. Once the model is trained, it is saved for future predictions. Additional parameters can be found in the UnifyML documentation. If necessary, the input data types of the columns can be modified using the input data types parameter. The training dataset is defined using the train sample size parameter, with the remaining portion used as the test dataset. Parallelism settings allow the model to be processed in parallel. The number folds parameter defines the number of folds for training and testing, while number partitions specify how the dataset is partitioned. If required, the PCA model can be applied by setting the Boolean value to true and specifying the PCA model name. Data cleaning methods include removing rows, removing duplicates, removing outliers, and filling missing values. The Fill with Values option allows users to fill null values or modify existing values. Data scaling can be performed using one of four methods: min-max scaler, standard scaler, normalizer, or binarizer. When using min-max scaler, the minimum and maximum values must be specified. If the dataset is previously saved in the cache, specify the input cache ID instead of the input table. Once the parameters are set, run this query. This query will execute in the backend of our UnifyML server. The output includes accuracy, test error, and the saved output model name. Now let's explore how to make predictions using the UnifyML Random Forest Classifier predict function. To make predictions, specify the input table name and mention the previously saved model name. Additional parameters are available in UnifyML documentation. During prediction, data cleaning methods such as removing rows, removing duplicates, removing outliers, and filling missing values can be applied. Data scaling options include min-max scaler, standard scaler, normalizer, and binarizer. If the dataset is previously saved in the cache, specify the input cache ID instead of the input table. To store the predicted results, use the Save to DB option and specify the output table name. If the table already exists and needs to be overwritten, set the Overwrite Output Table option to true. Predictions can also be saved as a CSV file by enabling the Save to CSV option and specifying the output CSV name. Run this query. This query will execute in the backend of our UnifyML server. The output of the UnifyML Random Forest Classifier predict function includes all input columns or feature columns and the target column, heart disease, which determines whether a patient has heart disease. Using this method, you can apply the UnifyML Random Forest Classifier to any classification dataset based on your requirements. Thank you for watching this video.